Good day. For those of you who do not know me, my name is Douglas Harder, and in this topic, we're going to look at linear operators on finite dimensional vector spaces. Now, in this topic, we will review some of the properties we saw in the last chapter for linear maps. We will now focus on linear operators on finite dimensional vector spaces. That is, we will be looking at square matrices. We will describe the properties we will be examining in this chapter. Now, suppose that a map A mapping Rn to itself is a linear operator. That is, A is in the space of all linear operators mapping Rn to itself. We have seen that all such linear operators can be represented by square matrices. And also, simultaneously, all square matrices represent linear operators. Given a linear map, we have seen that we can describe the range and the null space of that linear map. From these, we may deduce whether a linear map is onto or one-to-one. We deduce that if the dimension of the range equals the dimension of the codomain, then the map is onto, at least for finite dimensional vector spaces. If the dimension of the null space is 0, the map is one-to-one. Now, we saw that if we had an arbitrary map mapping Rn to Rm, and the dimension of the domain was greater than the dimension of the codomain, then there must be at least n minus m, which is greater than 0, free variables. Well, if there are at least one free variable, then there are infinitely many solutions to the homogeneous system of linear equations. Consequently, the null space has a dimension at least equal to n minus m, which is greater than 0. Therefore, the linear map cannot be one-to-one because many things map onto, for example, the 0 vector and every other vector that is mapped onto. If the dimension of the domain is less than the dimension of the codomain, the maximum number of basis vectors of the range is n, which is less than m. Consequently, the dimension of the range is less than the dimension of the codomain. Therefore, the linear map is not onto. Thus, only a linear operator on a finite dimensional vector space may possibly be both one-to-one and onto. So if the rank of A is equal to n, then it is onto, and there are no free variables, therefore it is one-to-one. If the rank of A is less than n, then it is not onto, and there is at least one free variable, and thus it is also not one-to-one. These are important classifications of linear maps. So, given a square matrix, we will now find 3 additional properties of these matrices, including the determinant, the trace, and the inverse of the matrix if it exists. Following this topic, you now understand what we will be covering in this chapter. You know that we are looking at the properties of square matrices, and you are aware that these properties will help us to describe the behavior of these matrices as linear mappings from Rn to itself. Here are the references, acknowledgments, the colophon, and a disclaimer. Cheers!